Hey everyone, and welcome back for another deep dive. Today we're diving into a topic that might send shivers down your spine. Arsenic. You want to know more about arsenic beyond his reputation as a silent killer? And trust me, there's a lot more to uncover. So buckle up as we explore arsenic, not just as a deadly poison, but as a chemical element with a rich and, just a intriguing history.
It's true. Arsenic's story is full of twists and turns. From ancient tools to its surprising presence in living organisms, it's a tale you won't want to miss.
Now I know what you're thinking. Arsenic, isn't that the stuff they used to, get rid of people?
The infamous poison of kings, indeed.
Exactly. And we'll definitely get to that part of the story. But first, I think you'll find it fascinating to learn that arsenic isn't just one thing. It exists in different forms, called allotropes, each with its own unique properties.
It all comes down to the arrangement of atoms. You see, even though it's the same element, the way those atoms are structured drastically influences how the substance behaves.
So it's like even though it's all arsenic, it can have different personalities depending on how it's put together.
Precisely. Think of carbon. It can be the soft graphite in your pencil or the dazzling diamond on your finger, all thanks to different atomic arrangements. Arsenic's the same way.
Okay, that makes sense. So different arrangements, different personalities for arsenic. What kind of allotropes are we talking about here?
Yeah.
Well, we've got gray arsenic, the most common form, which actually has a metallic appearance. Then there's yellow arsenic. This one's very unstable, almost evaporates easily, and unfortunately, it's the most toxic of the bunch. And lastly, we have black arsenic. Sounds kind of cool, right? But it actually looks kind of brittle and glassy.
And what's fascinating is that this concept of allotropes highlights how crucial structure is to a substance's properties. It's not just about the element itself, but how it's put together.
That's a great point. And speaking of structure, arsenic's history is just as multifaceted. Did you know it was used as far back as the Bronze Age?
Absolutely. They would mix arsenic with copper to make their tools more durable. It was a testament to their ingenuity, but even back then, they were aware of its toxic nature.
Right, they knew it wasn't something to mess with. But from what I understand, the symptoms of arsenic poisoning weren't always so clear-cut back then.
That's right, and that made it, let's just say, a rather convenient tool for those looking to, shall we say, discreetly remove someone from the picture, hence the whole poison of kings thing.
It's fascinating and a bit creepy how arsenic is woven into history. And it wasn't just an ancient thing, right? Weren't there some surprising uses for arsenic in more recent history?
Absolutely. In the Victorian era, arsenic was a surprisingly popular ingredient in, believe it or not, wallpaper.
Wallpaper. Get out of here.
Yes. They used it to create those vibrant green pigments that were all the rage. The problem was those beautiful wallpapers often hid a rather nasty secret.
Wow. Talk about risky home decor. I've seen old houses with that peeling wallpaper. Wouldn't want to be the one fixing that up. Good thing we know better now. It wasn't just wallpaper though, right?
No, it wasn't. Arsenic also found its way into cosmetics. Women would use arsenic-laced powders and lotions to try to achieve a fashionable pale complexion.
It's incredible how dangerous beauty standards can be. Those pale complexions came with a hefty price tag. But you know what? This actually leads perfectly into a discussion of arsenic's impact on human health, which we'll dive into right after the break. So we've been talking about how dangerous arsenic is, how it's toxic, but I mean, is it always the bad guy?
That's a great question, and it might surprise you to learn that arsenic, despite its toxic reputation, can actually play some unexpected roles in the environment and even, get this, in living organisms.
Wait, really? So you're telling me that even though it's poisonous, some organisms have found a way to deal with it?
Exactly. Certain bacteria, for example, and even some marine life have developed these mechanisms to transform inorganic arsenic, the dangerous kind, into less harmful organic forms.
So it's like less poisonous arsenic.
You could say that. They're basically changing its chemical makeup through a process called biomethylation.
Biomethylation. Okay, so break that down for me. What's actually happening in, like, simple terms?
Sure. So in the simplest terms, these organisms are basically changing the chemical structure of arsenic. It's kind of like how our bodies process different types of fats. It's not always about the element itself, but the form it takes. Like olive oil versus, say, trans fat.
Oh, okay, so it's not necessarily about whether it's good or bad, but like how it's structured and how our bodies interact with it? Makes sense. But this biomethylation thing, does that make arsenic completely harmless?
Well, it makes it less toxic, for sure, but it really highlights how life finds a way to adapt, even to things that seem, well, toxic to us.
Hmm.
And, speaking of adaptation, this reminds me of that controversial study from a few years back about a bacterium that could supposedly use arsenic in its DNA instead of
Oh,
phosphorus.
yeah. I remember that. Didn't that cause a huge stir?
It did. The initial study suggested that life might be even more flexible than we thought, maybe even able to use toxic elements in its most basic building blocks. However, further research actually revealed that while that bacterium, it could tolerate really high levels of arsenic, it wasn't actually incorporating it into its DNA the way phosphorus is usually used.
So it was debunked.
Pretty much, yeah. But that initial study, even though it was later refuted, it sparked a wave of new research. It really challenged some long-held assumptions in the scientific community. It just goes to show you how science is constantly evolving, always questioning and refining our understanding.
It's like even when we're wrong, it can lead to something really cool. But for now, while we're pondering the vast possibilities of life as we know it, what about the arsenic we know is a problem?
Right, exactly. So while arsenic-based life is a fascinating concept, we can't ignore the fact that arsenic contamination, particularly in groundwater, is a very real and serious threat to millions of people worldwide.
You're talking about places like Bangladesh, where naturally occurring arsenic in the groundwater is a major problem, right?
Exactly. And this is where it's so important to understand the difference between organic and inorganic arsenic. Organic arsenic, like what's found in seafood, it's bound to carbon and generally considered safe to eat. It's inorganic arsenic that's not bound to carbon. That's the one that poses the real risk to our health, especially in our drinking water.
Okay, so organic arsenic, seafood, generally fine. Inorganic arsenic, groundwater, potentially dangerous. It's like how mercury can be present in fish, but it's the type and amount that matters.
Exactly. And this distinction, organic versus inorganic, is so important when we're talking about arsenic contamination and how it affects our health.
And this actually reminds me of this really interesting case I came across while researching for this episode. The residents of San Pedro de Atacama in Chile, they've been drinking arsenic-contaminated water for generations.
Ah, yes. And studies have shown that they might have actually developed a certain tolerance to it. It's pretty remarkable how the human body can adapt to these challenging environments.
It's kind of mind-blowing when you think about it,
Yeah.
Like their bodies have figured out how to deal with this toxin that's been in their water for so long.
It really highlights the incredible adaptability of the human body, that's for sure. But it's important to remember that tolerance doesn't equal immunity, right? It's more of a coping mechanism, not something to strive for.
Right, more of a necessity than an advantage.
Mm.
So, knowing all this, what can people do to reduce their risk,
Mhm.
especially if they're worried about their water or food?
I think the first step is awareness. Find out if you live in an area where arsenic in groundwater is a concern. And if you rely on well water, it's always a good idea to get it tested.
Seems like a no-brainer, right?
Mm.
What about food, though? I know we hear a lot about arsenic in rice these days.
Right. So rice can accumulate arsenic from the soil, that's true. But the good news is that simple things like rinsing your rice thoroughly before cooking and using more water can really make a difference in reducing that inorganic arsenic content.
So it's not about avoiding rice completely. It's just about being mindful of how we prepare it.
Exactly. And like with most things in life, a varied diet is key. Don't rely too heavily on just one food source, and that'll help minimize your risk.
It sounds like knowledge really is power when it comes to arsenic. Knowing what to look for, taking those simple precautions. But for those listening who want to dive even deeper, what resources would you recommend?
Well, a great place to start is the TOEX map database. It maps out industrial releases of arsenic and other toxins and gives you this visual representation of potential risks right in your area.
Oh, wow. That is incredibly helpful. So it sounds like arsenic isn't this one-dimensional villain after all. It's a complex element with a really long and fascinating history.
It certainly is. And as we've seen, there's still so much to discover, from the very essence of life itself to the water we drink.
It really makes you think, doesn't it? This element that's often feared could actually hold the key to some pretty amazing scientific discoveries. And who knows what else we might find as we keep exploring.
It's a true testament to the fact that the natural world is full of surprises. The more we learn, the more we realize we don't know.
So true. Arsenic. It's a silent killer, a historical tool, a potential key to understanding the origins of life, and a powerful reminder that even in the most familiar elements, there are always new depths to explore. It's been quite a journey.
It has, and it really makes you wonder if certain bacteria have figured out how to manipulate arsenic in these incredible ways, what other possibilities might exist? What other secrets might this element be hiding as we continue to investigate its relationship with the living world?
Now, that is a fantastic question to leave our listeners with. What other secrets might arsenic be hiding? We encourage you to keep that curiosity alive and never stop exploring. That's all the time we have for today's deep dive into the world of arsenic. Until next time, keep those minds curious. It really makes you think about all the stuff we don't know yet, like arsenic, this element that we think of as so dangerous, could actually help us make some huge scientific breakthroughs.
It really shows how resilient life is, doesn't it? Even when faced with something we see as toxic, life finds a way to adapt, and who knows, maybe those adaptations could teach us something about our own world.
It's pretty amazing when you think about it, arsenic. It really makes you realize how powerful nature is.
Exactly, and it just goes to show how important it is to keep researching, keep exploring. What we know about arsenic today is only one part of a much bigger story.
So true. Well, that about wraps up our deep dive into the world of arsenic.
It's been quite a journey.
It really has. From a silent killer to a potential key to understanding life itself, arsenic is one element that never fails to surprise.
It certainly doesn't.
So to our listeners, keep asking those questions, keep that curiosity alive. You never know what amazing things you might discover. That's all the time we have for today, but we'll see you next time for another deep dive.